All right, guys, we're going to take a look at a couple of practice stoichiometry problems. And the first one that I want to work for you is 1986. So you were given this in class earlier this week, but I did want to take a look at how you would solve this. So everything in pencil up here is what was provided in the problem. So we do know that X, Y, and Z are all compounds, so that means that they are going to be a chemical combination of elements, and all of them have element Q inside of their compound formula. They do give us the masses of the compound Z and Y. They did not give us the mass for compound X. We'll find that later in the problem. And they give us some percent by masses of Q. So remember that the percent mass is always going to be equal to the part over whole times 100. So that means that if something is 64.8% Q, that means that over here the percent mass is equal to the grams of Q divided by the entire compound times 100. So we first have to figure out what is the molecular weight up here of our element Q, of our compound X. We need to know the molecular weight. And this is the answer, but I want to kind of take you through how I got that. So the first thing we're going to do is take a look at what they've given us. They've given us the temperature. Don't forget, any time that we are working in chemistry and using any of the gas laws, our temperature has to be in Kelvin. They gave us 750 millimeters of mercury. That's a pressure. Notice also when we use these gas laws, especially either the kitty cat formula or the PV equals nRT, we have to have our pressure in ATMs. So you'll see that I'm going to convert that in just a minute. They give us the vapor density is 3.53 grams per liter, so that gives us D. And they want us to find the molecular weight of X. There is a formula that is the kitty cat formula. The molecular mass in grams per mole is equal to the density times the constant R times the temperature over the pressure. And we remember this saying that kitty cats cover their pee with dirt, and this molar mass is supposed to remind you of a kitty cat. Okay, that's a terrible cat, but you guys get the point. All right, so all I did for the first problem here is plug in that molar mass is equal to dRT over P. You can see that I went ahead and just used a one step right here to change my millimeters of mercury into ATMs. That will be given to you on the test, the conversion, as well as the R value. You just need to know to use the one that has moles in it, because our answer eventually will end up being in grams per mole. So that's easy breezy part A. I got 88.1 grams per mole, and that's what I put up here as my molar mass or molecular weight of my compound X. So part B says that they want us to go up to part B here, determine the mass of Q that's in 1 mole of each of the 3 compounds. So basically, we're going to be doing the percent mass formula 3 times. Okay, so let's take a look at what I did. We have the percent mass, and now we have the molecular weight, 88.1 grams for our compound X. So all I'm going to do is say mass percent, which is 64.8, is equal to the part, which is the grams of Q that we're looking for, divided by the whole, which this is our whole, that's our whole molecular weight of the compound, times 100. So I'll show you my work on that. I took the percent mass and said that's equal to the part, which we're looking for, over the whole, times 100. So basically what you guys see here is I had originally just this part, percent equals part over whole times 100. That was my original equation. But then what I did was, to get rid of this 100, I divide both sides by 100, and I get 0.648 equals X over 88.1. I'm going to cross multiply and divide, and this is the grams of Q that are in the 88.1 grams per mole compound of X. And so I did it with Y, and I also did it with Z. So I hope that instead of just looking at my work, you would perhaps pause this and try to work it on your own, going back to get the answers at the end to check to make sure that you're right. So this was part B, something again that's related to what we've done in the foundation units. The only new part so far has been bringing back that kitty cat formula from pre-AP, okay? So this needs to be memorized for the test, the kitty cat formula, and obviously this was part of our unit, so this must be also ready for test. All right, let's take a look at question C. Question C asks us to calculate the most probable value of the atomic weight of element Q. So basically what we do here is we're going to be taking a look at what our masses were of Q in each one of those compounds. Because of the laws of definite proportions, we know that it's going to proportionally be put into each one of those compounds. So if I take a look at what our answers were 57.1, 75.9, and 38.2. We want to figure out what is the lowest common multiple between those three. Because again, the law of definite and multiple proportion says it's going to be proportional in a compound. So basically what I see is between this, and this, all of them have 19 as the lowest common multiple. So what we're going to say here then is that since 19 is the largest common number, it is going to be the good probable value of Q's atomic weight, because all of those numbers have 19 as a low multiple. All right, for part D, this is going to pull some stoichiometry in. So basically it says that compound Z, so we're just focusing on this guy right here, is going to contain C, H, and also some Q. And they tell us that we start with 1 gram of Z, and whenever it's oxidized and all of the carbon and hydrogen are converted, we have 1.37 grams of CO2 and 0.281 grams of water. Now, what you need to realize is that if you've got grams of CO2, you can get to moles of CO2, and then you can get to moles of C. If you have grams of H2O, you can get to moles of H2O, and if we get moles of H2O, we can get to moles of H. All right? For every 1 CO2, there's 1 C. For every 1 H2O, there are 2 H's. So what I have to do is figure out how many moles of C, how many moles of H, and how many moles of Z do I have in this compound, and then, Q, and then I can come up with my molecular formula for the compound Z. So let's take a look here. All right, so again, we have compound Z has a C, an H, and a Q as the elements that comprise it. So the first thing I'm going to do is take my grams of carbon dioxide and figure out how many moles of carbon are in this compound. I'm then going to do the same thing with water. How many moles of H are in the compound? Then I'm going to take my 1 gram of Z, because it does say that we have, when 1 gram of compound Z is oxidized. So I know that in 1 gram of Z, I'm going to have this many moles of Z. Now this number here came from the molecular mass of compound Z. So in 1 gram of Z, if I have 64 grams per mole, that means that I have 0.0156 moles of Z in that sample. So when I compare this number to this number and this number, I can see that these are twice as much as my Z. So basically I have 2 C's, 2 H's, and 1 Z in my compound, okay? 2 Z's and 2 H's and 1 Z in my compound. So if I know that I've got 2 C's and 2 H's, then I know that I have a mass of 2 times 12 plus 2, which is about 25 grams, okay? And if I know that my whole compound was 64 grams, I can take that 25 grams of C's and H's and know that whatever's left has to be grams of Q. So this is my compound Z. I subtracted my grams of C's and H's because I know that one C would be 12 and one H would be 1. So I would do 24 plus 2, around 25. So that gives me 38 grams of Q. I know that Q's, atomic weight is about 19 from the previous problem. So that means there's about 2 Q's that are going to be in my formula. So up here, I have written the formula out: C2, H2, and Q2. Remember, guys, on your test that we're looking for half the points in our bucket. I realize a lot of these problems, they do have easy parts, but they also have hard parts. So again, if you know the stoichiometry, you would be given points for things like this, okay? And you would be given points for things like this. So realize that although toward the end of the problems or throughout your problem you may have something difficult, realize that basically it's okay, because not all of it's going to be easy. Some of it is going to be hard, because getting half right is getting 100. So that's 1986. I am going to also work for you guys another one in the packet, which is 2003B. So I'm going to put that on a separate video.